Hi, I am Lebogang Digani of student number 2180-14603 from the Central University of Technology, and I will be taking you through what my project is about and how I came about designing the project. So the project aims to develop an automated railroad crossing monitor system which aids in reducing the chances of collision between the trains and the train rather and the vehicle crossing the rail. So taking you through the methodology, the first step was to identify the problem and write the proposal. And the proposal has your problem statement and the solution to that, and a short or a brief description of your project, right? And then following that, I listed all the components which I used, and I sketched rather the block diagram using my main components, showing all my inputs and outputs. So, and the third step, I used software EasyEDA to draw both the schematic and the PCB. And with the aid of software Arduino IDE, I wrote a code to program my microcontroller, which is my Arduino Uno R3. And then following that, I used both the PCB and schematic, which I have sketched on my third step to design the system, right? And then after that, I draw the flowchart for the design, which represents the flow of inputs and output information. And after that, to just bring the design to life, I made use of cupboards and scissors and all that to make an enclosure. Right, now for my proposal, like I said, the project name, there it is, it is a railroad crossing monitor system, and then it addresses a problem of accident caused by inappropriate control flow of traffic on a railway level crossing. And then to solve that, I made the design. That's where the design comes in. And then I will explain the project further on my flow chart, right? And then coming to my block diagram, I have my Arduino here, which is my microcontroller. I have all my sensors as my inputs. These are all my inputs and all my outputs, right? And then from there, I sketched, like I said, using EasyEDA, the schematic. This shows all the components connected to the Arduino, like right digital pins and on right analog pins. And then this can be converted to a PCB. Here it is. And right, explaining now the flow of the system. If any vibration is detected, not any, but if the vibration of the train on the railroad is detected, and then the ultrasonic will be triggered, and then when the ultrasonic is triggered, there will be warning displayed on the LCD, and then the servo is activated and the gate opens, right? And then if the ultrasonic is not triggered, but there's a vehicle on the route side, the PIR will be will be triggered rather, and then the servo is activated, allowing the gate to open and vehicles to cross over, right? And in dark instances, the LDR comes in. If darkness is detected, then the coils of the relay energizes, the LED is on, and all this information, but mainly for my main sensors, will be retrieved, and that's where the Wi-Fi module is taking place, and then the information is linked to ThingSpeak. And then this is all my information, my readings for my main sensors. This is the reading for LDR sensor, and then for my vibration sensor, and my ultrasonic sensor for the train, and my PIR for the vehicles. Okay, now to see the system in operation, we first take a look at which components are used and their functions in this system. I have made use of the ultrasonic sensor over here, which is generally used for detecting distance of an object, but for my project I have used it to detect the train approaching the crossing. This is the crossing over here. Secondly, I have made use of the PIR sensor, which is used to detect any motion of an object. I have made use of this sensor such that it detects motion of the vehicles approaching the crossing. If there's motion detected, the servo will enable the gate to open. But if the ultrasonic is triggered, meaning that the train is approaching the crossing, the servo will enable the gate to close, not allowing any vehicle to cross over. I have also made use of the LCD over here, which is generally used to display any information or warning. In this case, it will display warning for the drivers in the vehicles about the oncoming train towards the crossing. I have also used the LDR, which is just here on my breadboard, which can function as the light or darkness sensor, but for my project I've used it to detect darkness, such that in dark instances it will be triggered, and I have coupled the sensor with the relay over here, and when the relay energizes, the LED will flash on, providing adequate lighting on the entire crossing. The vibration sensor over here is used to detect any vibration of the train and will trigger the ultrasonic sensor. But for this basic design, I will be tilting the breadboard for generating some vibration, since the one of the train on the railroad is too small to be detected. All the information about my sensors will be sent to cloud via the ESP over here. Yes. And lastly, I have connected all my components to Arduino Uno. Okay, now let's see it working. Okay, let's now say that there's a train on the rail and it's about to approach the crossing, meaning that like I said, we'll have to tilt the breadboard for vibration. Okay, I hope that's enough. Okay, and then there's vibration on the railroad detected, meaning that the ultrasonic will be triggered. Now, in the train, it's approaching, and when it gets into a certain distance, the LCD will display train closer, gate closed, like it is right now. Okay, now let's say there's no train approaching the crossing and there's a vehicle on this other road. The PIR over here will detect the motion of the vehicle approaching the crossing, and the servo over here will enable the gate to open, allowing the vehicle to cross over. Now let's see. Let's wait a moment, and then the car crosses. Yes. And like I said, the LDR over here is used for detecting darkness, and in this case it is dark. Let me try to provide some light. In daylight, the LED will flash off, meaning that there will be enough light on the crossing. In dark instances, The calls of the relay energizes, enabling the LED to flash to provide adequate lighting on the crossing, like I said. And now this is all the information of my sensors, like I said, that is sent to the cloud via the ESP. This here shows the readings for the ultrasonic, and it is still reading. It was triggered somewhere there, and then it goes and goes and goes. This is for the vibration sensor. It was triggered just right there. Let us see for some other. Okay, the train distance, which is of now the ultrasonic sensor. It was triggered, and then it goes now that we are not there. And we have for our PIR sensor, it shows that now that we are not there anymore. It is now not triggered. It was triggered somewhere here. And that's all. Thank you.